Amber O'Hearn is a computer scientist known for her research into ketogenic metabolism and for a particular diet she's been on for a little over 9 years. She was brought up vegetarian, switched to a vegan diet later on in life, and after that switched to a low-carb diet, which helped her lose some extra weight. But she eventually gained all the weight back, and then some, over the 12 years she was on the low-carb diet. In November 2009, she began eating only animal-sourced foods, primarily just meat and occasionally eggs and dairy. But the most important benefit of the diet was very unexpected. Amber had been diagnosed with major depressive disorder 12 years earlier in 1997 and was put on antidepressants. Over the years, the depression had gotten worse, and she was also diagnosed with type 2 bipolar disorder. This all went into complete remission on the animal foods diet, and she's been off all psychiatric drugs. The only time she's had symptoms are when experimenting with plant foods, supplements, or from drinking too much alcohol. Amber was gracious enough to meet me for an impromptu discussion in the airport right before her flight, even though she had just been on a fishing boat for about 8 hours.
So could you comment more about what you think plants' role in our survival and our evolution would have been?
Sure. So Wrangham famously hypothesized that we are human because of cooking. And I think that the reason he's made that hypothesis is because in order to get enough energy out of the plant foods that would have been available, which were starchy, in order to get starch, you would have needed to cook it in order to get it out of the very fibrous plants that there were. Mm-hmm. On the other hand, meat and fat, you can simply digest raw. And so we could have eaten long before there was fire, we could have gotten what we needed out of meat, whereas we couldn't have gotten very much out of starch.
Mm-hmm. Okay, and then I think our fuel metabolism is really important because we required so much energy for our huge brains. As you were saying in your talk, we needed 25% of the energy budget goes to the brain for an adult, 50% of the energy budget goes to the brain for a baby. So maybe babies would have something interesting about fuel metabolism that you could share.
That's right. So obviously we can use glucose for fuel, but at the time frame that we're talking about, it was, it took a couple million years for our brains to triple in size, and at the same time our colons were shortening. And our pre-human ancestors were likely herbivores like the great apes that are our closest relatives now. And they were getting most of their energy by fermenting fiber in the gut into fat. But you need the colon to do that, to house the microbes that can do it. Mammals and vertebrates can't actually digest fiber. And so if you take away as much colon as we had taken away, then you really don't have that choice anymore. And it was so much earlier than any evidence that we currently have for widespread use of fire that the plausibility of a carbohydrate-based diet is really quite undermined. Mm-hmm. And you're right, babies in particular, evolution really favors the young. The young have to survive. Yeah. And the brain is so important to what we became. You can't really imagine an environment where our brains weren't supported consistently in order for us to have gotten to where we are. So I like to look at the babies as meeting the baby's needs has to have been done. Mm-hmm. And something that's very special about humans is that our brains continued to grow long past not just gestation, but long past weaning. Mm. And so we needed to provide a very high level of energy and a high quality of nutrition all the way through that growth.
Mm-hmm. What is the state of a baby's metabolism? Like, how does it differ from an adult's?
Well, it doesn't differ very much from an adult if that adult isn't eating carbohydrate. Babies are actually in ketosis if they're breastfeeding, while they're breastfeeding. And not only that, even if you've weaned them onto something like cereal, they are so geared toward ketogenesis that they will go quickly back into ketosis within hours. So you could, unless you're waking your baby to feed them cereal throughout the night, you couldn't keep a baby out of ketosis if you tried.
Wow. And this reminds me of something that I read a while back. It's from a doctor, Dr. Muneta, and he was talking about how looking at the blood going to the placenta, it looks like the placenta is already, or the fetus is already living on ketones from pregnancy.
It's true. Yeah, I've read papers on that as well. I don't remember the authors, but the placenta is full of ketone bodies, and you don't have to. The mother doesn't even have to be in ketosis for that to be true. It's such an important fuel. It's not just a fuel. In fact, ketone bodies are actually used structurally to build the brain. The brain's mostly fat and cholesterol if you take the water away, and so you would think maybe we just have fat flow into the brain and build the brain out of that, but it turns out that most fats don't cross the blood-brain barrier very well. But ketones do. So I like to think of them as a kind of transport form to get them across the blood-brain barrier, and then they are used, the carbon backbone of the ketone bodies is used to build the actual infrastructure of the brain.
Structure.
Yes.
Okay.
Next, I asked Amber about whether babies being in ketosis had anything to do with gestational diabetes, which is a diabetes-like state that can appear during pregnancy.
So, there's a lot of hesitation and worry about ketosis during pregnancy several years ago when there wasn't as much current experience with that. And I think there's a lot of confusion because pregnant mothers are often tested for ketones in their urine. If they're spilling ketones, it can be a sign of, it's actually used as a sign of dehydration. Pregnant mammals of all kinds are actually more likely to be in ketosis than non-pregnant counterparts, probably because of that excess fuel need. So in the traditional doctor's office, you'll get a urine ketone test, and if you're showing ketones, they will try to make sure you're eating enough and that you're drinking enough. And the confusion with the ketoacidosis and gestational diabetes, I think, is really mixed up in the practitioners' minds.
Why don't we talk a little bit about the nutrients necessary for maybe the nutrients, and then what foods would have those nutrients that are necessary for building the brain?
Sure. So besides energy, there are many things that are absolutely critical to proper brain development. And if you don't get them while you're developing, they can cause lifelong deficits. So one kind of important nutrient are some long-chain polyunsaturated fatty acids. DHA is really famous. Everybody loves DHA and knows about it. But there's another one which is an omega-6, and so it's often not as lovingly talked about, but it's equally important, and that's arachidonic acid. These are important for the phospholipids in the brain. And they're important for pretty much every function that you can imagine needs to have those properly incorporated. Along with those, we have a selection of minerals like iodine, iron, zinc, and we have vitamins like B12, other B vitamins, vitamin D, vitamin A are all critical for brain development. And one thing that's important to understand is that many of those are difficult to get in plants. Some of them are impossible to get in plants. B12 you can't get in plants. DHA, I think you can technically get some from algae, but it's not something we could plausibly have been getting in the evolutionary environment. And so if you put all these needs together and you think about how not only is it difficult to get those nutrients out of plants, not only are the plants seasonal and many of them toxic, but some of them have inhibitory factors that make it really hard for us to absorb the nutrients, or they would interfere with the absorption of those nutrients. And so meat, if you look at the ruminant animals, you can actually get every nutrient that you need if you're thinking about consuming many parts of the animal. So you have the muscle meat, which will provide the protein that you need. And humans need a lot of protein, especially when we're growing. And then the fat could be found in their subcutaneous fat and in their marrow. And also the ruminants that were available at the time were much larger. They were the megafauna that had a lot more fat on their body. So don't imagine a deer, imagine a mammoth that's just overflowing with fat stores. And then they also, if you eat the brain, then the brain has what our brains need, coincidentally. It has that DHA and the arachidonic acid that are so critical that otherwise we wouldn't have been able to get without access to fish, which the evidence appears to have been a bit later in the time period that we're talking about, although it may well have become important later.
Mm-hmm. Do you think there's some perfect balance between plants and animals that could make you, live an extra 10 years or something like that?
Well, I try to keep my mind open to such ideas, but as far as evidence that I've seen anecdotally, I know a lot of people who feel their absolute best without any plant intake at all. The arguments for a hormetic effect from the plant toxins is interesting. I think it's really backed off because the people who are advocating for plants, many of them have realized that they can't compete with animal-sourced foods for nutrients. There's nothing that we know of that is necessary for health that you can't get in an animal-sourced food, and usually at a much higher, more bioavailable rate. So people they think, well, if we were eating them in the past, and I do think that we used plant foods as a fallback. It's great to have another way to survive if there are times of stress. But people are thinking, well, if we ate them, there must have been a reason that we ate them, and they must be good for you in some sense. I don't buy the hormetic arguments in particular that are going around right now, because the way that those work is that they cause oxidative stress in the brain, to which you respond by creating so much antioxidant that it more than compensates, and so you're better off than you were before the stress. All that's fine, perfectly logical, but under a ketogenic metabolism, you already have that going for you, endogenous antioxidants, so much farther than you could get from a tiny bit of phytonutrient. I like to call it phytotoxins or phytochemicals at the very least. So I just don't buy that if you're already eating a ketogenic diet, that those plant additions would actually buy you anything. And then there's plenty of evidence that at least for some people with certain issues, and maybe it's only the sick, I don't know, but some of us are so sensitized to those toxins that there's no question that we're worse off with them in.
What do you think about plants as medicine?
Gosh, I'm very much in favor of medicine.
Okay.
And if you get that from a laboratory, or if you get that from studying a plant compound and you figure out that it has some kind of property and that helps someone overcome an infection or a disease, I'm absolutely not opposed to that at all. What I am opposed to is saying, eat little bits of these whole plants, not the drug that you've isolated from it, in order to somehow preventatively stave off something that the medicine would be fighting. That would be like saying, take little bits of chemotherapy. But that sounds like a horrible idea, right? And I think that's what the argument often boils down to.
And I think we have time for, just one more question. And this is kind of maybe a novel topic that I don't think too many people are looking into. It's the question of fermented meat. I heard of this paper because you had tweeted about it, and it's titled "Putrid Meat and Fish in the Eurasian Middle and Upper Paleolithic. Are we missing a key part of Neanderthal and modern human diet?" Do you think fermented meat could have any role in our evolution?
Well, it's a really interesting question. Our digestive system in some ways seems to be more like a scavenger's even than a carnivore's, and maybe that's because we did start out as scavengers, going after what's left over from the carnivores. But another question that we might have is, if we're taking down these huge animals, even if we're sharing it among a big tribe, how long can we keep that before it starts to age? For some reason we prefer our meats aged nowadays even. So I think there's definitely an interesting story to be found out there. I don't know what the answer will be, or if the fermentation will actually add a benefit, but I think that it's absolutely not something that would be foreign to us.
Just to add a little, and maybe you could bounce off of this, reading through this paper, it sounds like the oxidation of the fatty acids, apparently it's less oxidized, even less than if you had refrigerated the meat. Fermenting the meat prevents the fatty acid oxidation better. And then you have like more vitamin K2, I think vitamin C, and there's another nutrient. But had you heard anything
That's fascinating. You know, I tweeted that paper and I haven't circled around back to read it thoroughly, so I didn't know that fact from it. But one thing that I find interesting about fermentation practices in general is that because we lost all that cecum and colum, we're kind of had to outsource fermentation if we wanted to have that digestive process that in other animals is taking place on the inside to take place. So you could think of those fermentations as having an exterior gut, letting it ferment, letting some of the nutrients get fermented out that we otherwise wouldn't have done, and then you can just have the product of that. So that might be a way to think about it.
Okay, well, I think we're just about out of time, so thanks so much, Amber. Appreciate it.
Thank you.
It was really good meeting you.
Great to meet you too.